I want to discuss a useful new feature that's in Rational Performance Tester version 8.6. They call it a secondary request processor. And before RPT 8.6, RPT would fetch whatever is recorded. But with this feature, you are allowed to provide a reference with a regular expression that matches more than one element on a page. And RPT will fetch all the elements that match. There are some restrictions. All the request headers for all the different elements must be the same. All the verification checks on all those elements must be the same. In other words, you only get to specify them once, and they're applied to all the pages that show up. And all the references that are harvested from a fetch page must be the same. But in general, it's not a problem to meet those restrictions because the use case is when you're, for example, traversing a tree, and all the pages are more or less the same, but there's a different number of images on each page, and you don't know in advance how many images will be on a particular node in the tree. You would use this secondary request processor to say fetch all the images on the page. So there's two ways to do the substitutions. You can do it from a reference in a page, in which case you would make the regular expression so it matches all occurrences, or you can do it as output from custom code, in which case the custom code would put the data, the matching URLs, in something called an array variable, which is new to RPT 8.6. And I'll show you both ways of doing that. And since you're simulating a browser, and a browser would fetch images in parallel using more than one connection, you also get to use more than one connection to fetch these images in parallel, and you get to say how many connections to use. The first case I'll show is how to use a secondary request processor from a reference and a substitution. So I'll show how to substitute from a reference on a page, and I'll also show how to view the fetched items in the test log. Turns out there's two ways to do these substitutions, and I'll show you both ways, one of which, the first one, is easier, more automatic than the second way. And the second way is useful if you have not taken the first path and find yourself floundering around. So I'll give you some details there. First, I'll show you the preferred way to manually create secondary request processor. This is a preferred way if you can do it. Alright, so first I select the line that I want to create a secondary request processor for. Then I select the URL that I'm going to substitute for, and I say find and substitute. And it finds all the matches, or it tries to find all the matches. And what it's saying here is that it couldn't find any matches. And it says, would you like to turn on the include potential matches options to display every matching string that could be used as a reference? I say yes. And that is key for making this to work. And you can turn on include potential matches, and it found one there. And that's the key. You can turn that on manually or not, but this way is the automated way. So then I select that, and it looks for matches. I found a number of them. And I'm going to substitute the one that I was working with. And now I want to edit the reference properties. The name of that reference I should change, but I didn't because I'm just demoing. And it shows the reference here. And the important thing is that this is an all occurrences reference. And that's crucial because that's how a secondary request generator knows to pick up more than one matching element. And here it created it automatically as all occurrences. If I had done it manually, I would have to go and set all occurrences to true by myself. And I'll show that in the next segment. Before I do that, I will mention that I'm using a technique in this demonstration that I talked about in lecture 11, where I took an existing script and system under test changed, and now I'm fetching some elements that were not there before. And so I did some copying, pasting, and made my own references to these new items. Now, one thing about these new items is that sometimes there's one of them and sometimes there's two of them. And I don't know in advance, so that's what I'll be demonstrating. So here's the test, and there's the CSS files. And sometimes there's one and sometimes there's two. And what I'm going to do is I'll make a secondary request processor out of this reference, or this substitution, this page. So I take the login CSS URL and I'm going to search for it and see where I find it in a page, and I found it twice. And that's because I copied and pasted it twice into this existing page. And you can see APC copied the next two here from a newer recording. And so there's two of them that have a similar right boundary and left boundary, which is add CSS to head login portlet, and then a semicolon and some other markup on the other side. So I'm going to create a reference here. I get to give it a name. I'll call it login related CSS, which is a descriptive name. And I'm going to edit that reference because this is just fetching one of them. It's fetching a specific occurrence of this, just the first one. That's not what I want to do. So I'm going to tailor this a little bit. The regular expression, and that's fine. And now what I'm saying is get all occurrences, and that's important because it's going to match more than one if there's more than one present, and we'll fetch both of those. And that's the key feature that's being described here. And I can just make it a little bit more exact. I'll verify that. That didn't match. Because a parenthesis is a special character for regular expression, and I need to escape that. So a little bit of details on how to deal with regular expressions. So I'll escape that, and now I'll verify it, and now it works. So I was just tailing the regular expression. And now it's going to look to see if it can find places to do the substitution. And I'll say yes. And it found the one I was dealing with in the first place, the URL. So I say, well, that's the one that I want to do the substitution for. But I'm not going to do the substitution here because I want to turn it into a secondary request processor. So if I was only just doing one substitution, that might work. But I need to do a secondary request processor. So I highlight that line where I want to do the substitution, and I create a secondary request generator. And that's a new feature here. And what that does is it will comment out the old one, the old fetch of login CSS, and we'll make a new one. And on that new one, I get to do a substitution. That's the one that's commented out. You can see it's got two little slashes next to it. And so it's kept there in case you want to back out of this change. You can always put that one back. So here's where I need to do the substitution. I highlight it and I say substitute. And since I just created that, it knows that that is one I'm likely to want to use. And so I substitute from that. And it found the other one. It found the one that was commented out when I was asking, do you want me to look for others? There's really no reason to look for others, but I just do it out of habit. And that's where the substitution is. And there it shows the max number of simultaneous connections. The default is 2. And depending on what browsers you might want to emulate, you might want more connections than that. 2 is the default. It'll fetch both of those in parallel using 2 different connections. So there is that substitution made. Alright, now I will show how to view the fetched items in the test log. So I execute the test, and then I look at the test log, display test log. And I come down here, and there is the secondary request generation start. And you can see it fetched 2 of those. So with one secondary request generator, it fetched 2 CSSs. And if there's only one on the page, it would only fetch 1. And if there was 10 on the page, it would fetch 10. And so that's the new feature. And you can see the request and response headers for both of those. And so that saves you a lot of time compared to the way you used to be able to do it. And now I'm going to show how to use output from custom code in a secondary request generator. The custom code parses the web page. You put individual items in a new construct called an array variable, which is a test variable and is accessible from custom code. And then you create a secondary request generator at the URL, and you substitute into the URL from the array variable. And so it's some very specific custom code. And before I get into the details, let me give you a quick overview of what I'm about to show. And I'm going to show that using a test that's already got this done to it. The test has got some variables, and I put them in a container, and they are a new type of variable. I've got 2 of them, and they are array variables, and that's new to RPT. And what I'm going to show here is that I've got some custom code that will populate those array variables. So if you look at the names of the array variables in the test script, you will see that they match the names of the variables that are mentioned in the custom code. And there they are. These lines in the custom code actually populate those array variables that are in the script. And then I've got some substitutions that I'm going to make, some URLs that I'm going to populate with those array variables. There's 2 of them in this particular case. So I just wanted to give an overview. I'm going to go into the details of that now, but I just wanted to give a quick look at what I'm going to try to accomplish. And there I'm showing how to add an array variable declaration. So first you have to add an array declaration to your test. And I added 2 of them. I put them into a bucket. And now I'm going to use them from the custom code. So you see here, the important things are I declare an IDC array and I give it a local variable name, similar array collection hrefs. And I call a built-in function that's in RPT data var util get var. I give it those parameters, one of which is array collection array, and that is the name of the variable in the test. So this gives me access to the test variable. And the rest of the parameters are hard-coded. So the first thing I do with an array is I clear it. A similar array collection hrefs clear. I'm just trying to make sure that if there's anything left over from the last iteration of this test that we're not using it, because each time this iterates and runs, I want new information in there. And in this case, I've got 2 array collection head refs, and one's for head CSS array collections. I have to keep them in different array variables because they have different headers, different request headers. And as I said, to use one of the secondary request generators this way, you need to have all the exact same headers. And these 2 sets of array collections have different headers. So I have to fetch them separately. And similarly on that second IDC array, I say you name it head CSS array collection array. And that's the name that's used in the test. And that's how I'm going to populate that. And then the next thing I do is I clear that, make sure it starts empty. Then I parse the page, and that's going to be very specific to you. It pulls out an array of links. And then I call a method that's called put2array. I'll show that in a second. And then I do it again with both sets of arrays. Let me just show you that put2array method. First I check my input, make sure it's not null. And then I look for a bunch of things, RA collection in particular. I make sure it's not deferred. That's very specific to Portal. And another thing that I also do is, if it's one that I do care about, if there's an ampersand URL that's spelled ampersand AMP semicolon, I'm converting that to an ampersand. In other words, RPT is not going to do URL encoding on these for you. You have to do it yourself. So that's what I'm doing there. I'm turning an encoded ampersand into a real ampersand. The next step is I'm just making sure I'm not putting duplicates in an array. Probably don't need to do that. It turns out I didn't need to do it, but I was just being extra careful here in case the URL showed up twice on a page. And then I figure out if it's a duplicate, and if it's not a duplicate, I ask which array variable belongs to, the head CSS one or the other one, and then I do an add to the right array. And there you have it. That's how you add. That's how you create these array variables that you can then use in the test. And once again, here's the URL, and I did substitution, and I picked the array variable, and it just like substituting any other variable into a URL. So in summary, the useful new feature in RPT 8.6 that I demonstrated here is called the secondary request processor, and it saves you a lot of time when scripting, a lot of time and nasty scripting code, because now you can just say, fetch me all images that match this pattern. And if there's 5 of them, or 4 of them, or 3 of them, you don't really care. RPT will figure it out. And there's 2 ways to do it. You can do it from a reference on a page, or you can do it with custom code. Once again, you get to specify how many simultaneous connections to use. So there you have it, a useful new feature in RPT 8.6.